Good morning. First, I would like to ask a couple of questions so that I know who I'm talking to. So, who of you has completely no experience with distributed version control systems? Any? Okay. And who of you has no experience with Mercurial? Okay. Who of you have any experience with what I'm talking about? So, or what I'm going to talk about Mercurial Queues. Okay, Wolfgang is the only one. Oh, okay, so let's start. So first, I'm going to cover some basics of a Mercurial version control system. Then I'm going to talk about the Mercurial Queues, and then there'll be some final notes. Okay, so the bigger picture. Mercurial is a distributed version control system, pretty much like Git, monotone, bazaar. Well, there are many of them. Actually, I don't know how many of you know this. It started almost the same day as Git, the development, and originally it was supposed to be used for Linux kernel, and then it turned out that Git would be probably better for that. Now, this is the basic, what the basic workflow looks like. There's a AG repository somewhere outside in the cloud, for example, which somebody had to create using the init command. From that, you can pull or push your data to your local copy, which you had to first create by cloning the outside repository. And then you use many commands, but to synchronize your work with the local tree, you use update and check-in commands. Now, changes go directly into the repository history, so there's nothing like index in Git, which is not really nice. And the other thing is that history is immutable, and that means that it's set in stone. Once you commit a change, it's hard to get rid of it. It is possible to do that, but it's a bit complicated. Now, this can cause several problems. Changes are difficult to change. So if you mess up the commit message or do a typo in the patch, it's quite difficult to get rid of that. Working on more things at the same time is again difficult because if you are working on two things, developing two disjoint features, you basically have to use branches and then merge them somehow, or you can just intertwine the commits. So you have 10 commits from feature A, 2 commits from feature B, then again some commits from feature A, and so on. Doesn't look nice in the history, and it makes bisecting more complicated. It's quite difficult to maintain patches against source that is maintained in Mercurial repository, because basically you have to rebase your patches all the time, and you probably don't want to put your changes in the upstream tree for some reason, because that's what it is. You're maintaining a patches that probably weren't accepted upstream, so you get plenty of troubles with getting them applied, and then if you do some development, you have to do it somewhere else. So again, mess. And that means that merges are inevitable as well, as I mentioned. If you are developing several things at once, you have to merge. If you are developing your own features and it takes you quite some time because it's something on a larger scale, then the upstream doesn't wait for you and you have to merge again. And it also brings some headaches. So the classic example is that some mistakes are just undroppable. So if you, for example, commit something very important which shouldn't have been committed, like your SSH keys or the nuclear launch codes, or even worse, your GNU-PG private key, then it stays there forever. You can't really delete it. And that's what the Mercurial FAQ says. Good luck cleaning up your mess. But that's actually trouble of all distributed version control systems, because once somebody pulls the changes from you, or you push them into the outside repository and then somebody clones that, then you really have lots of fun talking to all those people to get rid of that and so on. But that's actually, oh, sorry. Wow. Yep, we're somewhere here, right? That's true for all version control systems, and it's actually true for all public information sharing, Facebook and friends. However, this is intentional, and it was a design of Mercurial, and it has some good reasons. Opinions vary, but one of those things that it teaches you is that you really should think twice before you commit something. As I said, opinions vary. People using Git probably won't agree with this, but I actually think that there are some differences between people using Git and Mercurial in their points of view on code development. Now, what if you just wanted to do the exact opposite, or actually the things that I mentioned are difficult? So that means have a couple of patches and pour them as the upstream changes. You want to change, hide, delete stuff you already committed. This means that you committed it into your local repository and not into the upstream one. And you want to do it easily as well. No fiddling with the binary data or so, things like that. And you don't want to merge all the time. Question mark. So, what? There is something that can do this for you and can do something more, and it's not Git, or actually Git index. It's Mercurial Queues, like this. Quantum mechanics, sorry. Mercurial Queues. Now, it's an extension, as most of the Mercurial, it's written in Python. It's actually distributed with Mercurial for some time by default. The original idea is based on Quilt, that was written by Andreas Grünbacher, I believe. And the extension itself was written by Chris Mason, who is also the author of BTRFS. That's probably what he's most known for, right? Now, let's take a look at a different picture. So, MQ builds on top of regular Mercurial repository, and it actually maintains the patches, the changes you are making to the repository as a set of patches. That's basically the idea behind Quilt. You have a series of patches, and you want to apply them or unapply them, edit them. Now, there are some commands that you can use to update the patch and put it to local repository. You can also take a change set from the local repository and turn it into a patch. In the repository history, then it turns out that it looks like an ordinary commit. Not really ordinary, it's a bit special. But it looks like a normal commit. And then you can work on it, update it by refreshing it with qrefresh, and then when the time comes and you finish with your work, you can push it back into the local repository and then publish it. Now, this is interesting. This looks pretty much like Git index, right? So you have some intermediate stage where you can try your changes, and if it doesn't work out, then you just change it, delete it, discard it, whatever you like. But that's not really as helpful as it could be, because you're still stuck with one thing that you can change, but if you want to work on two things at the same time, it doesn't really help a lot. So, the thing is that the patch is stored somewhere else. It's not part of the repository itself. It's stored somewhere else. And that means that the picture can change, because you can put other patches to the first one. And the patches you can apply, unapply, and basically the two circles are what Quilt is. So you have basically Quilt stacked on top of Mercurial repository, but it's integrated into Mercurial. Now, that sounds interesting. And what does that mean? We have a couple of patches. We can push them on the patch stack, then edit them, refresh them, pop them out. We can reorder them. But that's not really all. And it's not very much. I mean, you could have used Quilt for that. Now, and this is where Mercurial comes into the game. Because, as I said, you get a pile of patches, and that's it. So what's the next logical step to do? Any guesses? No? You use the solution that you already know. So instead of this, where you got pile of files, you do this. You create another Mercurial repository of the patches. And the next logical step is that you make another repository of the patches. So basically, you have several repositories of patches. This looks interesting. So we'll put it in the really big picture. I'm sorry it's a bit messy, mostly because I didn't want to pillage websites, taking pictures from them without asking. This is what Mercurial Queues look like. You have local repository, local copy of repository, and between your work copy and the local repository can be a set of patches that are handled as another Mercurial repository. Which means that, for example, if you want to have some patch set against upstream, as the upstream evolves, you pull the changes into your local repository, then you apply your patches. There are some conflicts, changes, so you update it. And when you're finished and you got a patch set that works well with the latest revision you've pulled, you can check it into its own revision history, and there you go. You got a safe place to return when something goes wrong. So the same goes for developing a feature. You are developing some big thing for something even bigger, like for Mozilla. One interesting thing that was developed recently was the backend for storing email messages, which were stored in mbox format. And the point was that you want to make something generic where you can decide in what format they are supposed to be stored. So that's quite a lot of rework, because it's basically revamping half of the backend of the mail system. So what you do, you start developing, you got patches against some tree, you develop it, the underlying upstream changes, and once or twice a week or month, when you think that your changes are worth a try with the new version, you pull the changes from the outside, update the patches, and try it out. And because the feature is quite big, you definitely will make some mistakes. So when you get a working proof of concept, let's say, you can check the patches into their repository, and when you later make a change that really doesn't turn out to work as well as you imagined, then you have a snapshot that you can go back to. Basically, you want to do that quite often, right? And that's something that, as far as I know, in Git is slightly less convenient. Now, Fractals anyone, I believe you see the possibility of putting another Mercurial queue into the patch repository itself. But that would be quite impractical because you'll be then dealing with diffs of diffs, later with diffs of diffs of diffs, and so on. So that's probably not what you want to do, but it's possible. Now, summary, second part. Mercurial Queues represents the patches as a series of special commits in the history. By special, I mean that when you have patches applied, you can't pull changes into your repository. This is just a soft lock. You can override it, but it's usually good practice to obey what Mercurial tells you. When he tells you you can't do something, there is a reason for that because you will probably mess up. But the idea is that if you have patches applied, then you just unapply them, update the tree, apply the patches again, correct any possible conflicts, and you get a working copy again. And it's quite easy. The patches are stored in the special directory .agg, which is where Mercurial keeps all its files. And in this directory, a special subdirectory is created for every queue. And of course, if you want to use the possibility to track the changes, then there is another .agg created in this subdirectory. And the subdirectories are fully fledged Mercurial queues, which you can, for example, share with the outside world. So you can publish them, and there you go. Your friends can change your patches quite easily, and they can push them back. So you can actually even work with somebody else on the patches. Yep. Now, so the use cases. That's pretty much what I mentioned. You are developing against moving target, have a couple of patches, update, easy. You don't have to do any rebasing, which you would have to do quite often. And moreover, the changes are kept separate from the main repository. So if you don't want to publish them, you just have your own local copy that doesn't appear in the history, and it's somehow floating around the main tree. You can prevent merges in the history because you can import some of your change sets. For example, if you do some development and then you realize that it's time to pull from the outside, and for some reason you committed your changes into your local repository and didn't publish them, then when you pull changes from the outside, you basically create two branches which you have to merge somehow. Now with Mercurial Queues, you can import these patches into your changes into the queues, then unapply the patches, and after that you got only one branch, and then you apply the patches again, and no merge, but your changes are in there. You can change unpublished history. Once you publish your changes, then if you do this and push it out again, you create another head because the commits are different and the changes are different. You mess up. So you only change unpublished history. Exactly as I said. Move the commits into MQ, update them, put them again. And there's one more thing you can do. What if, for example, your patch queue in MQ looks like this? Yep, that's the some of the patches from OpenSSH package. So you can quite easily maintain the patches that go into a package. For me, that works, at least. Now, we don't have time for any practice, so I probably won't try to read it not to insult those whose mother tongue is German. Anyone knows where this quotation comes from? Right? It's from Faust. That's, I believe, Mephistopheles talking to some guy. And it says that gray is all the theory, but green is the golden tree of the life. Which means that if you want to learn something, you have to practice it. Now, if you want to practice it, this talk definitely didn't give you enough information, so you will need some. Mercurial is quite known for its good help. HG help lists the main topics. Basically, you can ask for help for any command, extension, and sometimes keyword or similar things. One to note is, I believe it's called phases, which explain how Mercurial differentiates between various stages of the comets. Which is important because sometimes it happens that Mercurial doesn't get it completely right and thinks that your commit is published when it's not, or you know that you have pushed it somehow, but you have full control of the repository you've pushed it in. Then you can convince him that it's okay to change the commit, mark it as not public, and there you go. You can change the history that's published, but you know that it won't bring anything. This is quite a good guide for Mercurial Queues. It's terse, but quite good. And there's this beautiful blog post on which I basically based this talk. Now, I believe we have about 1 minute for questions. Any questions? I thought so. That means that the talk was either terrible or excellent. Sorry? For Git, I don't know. You have to use Mercurial. Now, thank you.